Okay, sorry about that. And I should apologize for interrupting you. I just wasn't sure. Jeremy Reese had me a little thrown with the mystery speaker part of it. But so let me see. I will unmute you again. And I think we had one hand up, and that was Evan. Ah, there we go. Go ahead, sir.
I'm sorry, I just hit the wrong button.
Oh, okay.
I was clapping.
Oh, no worries at all. No worries at all. Well, okay. Does anybody else have questions? And if not, we could just go to open discussion. But
I actually have, if nobody has questions for the mystery guest, I actually have a couple.
I got a question here before you go on, Mark. Yeah. Okay. A mystery guest. Please tell me how the heck to make these things work. Okay, because I pulse these coils every which way to Sunday. I cannot make this thing amplify a magnetic beam.
I don't think the intention. Oh, I don't think the intention is to amplify a magnetic beam at a distance, really. I mean, maybe. Well, so if I were to optimize this device,
Bushman, the inventor, that's exactly what it's supposed to do.
Yeah, I don't think that's like he's probably. I don't know what he's doing, but if I were to maximize the field emitted by this thing, I would basically make like a solid sphere of magnetic material with a small hole coming out somewhere, with all the poles on the inside. Basically, if you have a really hard magnet like that, the preferred path for the magnetic field out of the center of that is wherever there isn't that very hard magnet. The permeability will just be too low any other direction. So I think the point of that was to concentrate the amount of magnetic field even more past what you would have been able to get with just those magnets, and the amount, what was it, the BH max, the maximum field that they can sustain.
Yeah, well, I mean, if you look at the design of the Bushman beamer, and it, as a predecessor to the David LaPointe magnetic system, he effectively just has a magnetic beamer, only instead of using just 4 or 5 magnets, he ends up using a plurality of magnets around the hemisphere, all pointing in towards what will be the focal point of that hemisphere. So it's just a different approach to basically doing the same thing. You're synthesizing a monopole on a macro scale by using a plurality of individual magnetic components. And
this is important. Some people were confused about this in the comments. So what I forgot to mention this. What I was trying to say about monopoles here is it's kind of a matter of semantics. Any dipole is 2 monopoles next to each other equivalently. And the thing with the vacuum in our universe is it's really easy to create monopoles of electrostatic stuff because particles have net charge. It's vacuum really doesn't allow that so much with magnetic fields, but you can create effective monopoles by arbitrarily moving the north and south poles relative to each other.
Well, right, and like an example of that would be buckyballs, right? C64 fullerenes, because if you take a look at the assembly of those atoms, what you end up with is a negative charge pointing towards the center of the buckyball and ending up with a positive charge on the outside, which actually allows these fullerenes to not absorb but adsorb, as in electrostatically attract other free radicals in the system that have either a neutral or a net negative charge. And so this is one of the reasons why if somebody eats something toxic, one of the first things that medical staff will do is feed them a huge amount of either just graphene or graphite or buckyballs in order to clear the system out and pull all these toxins out, because they're electrostatically charged. But the thing is, they're not actually monopoles. They really don't exhibit true monopole behavior if you send them through an EM field, because they do have a balanced number of positive and negative charges. It's just that the geometry of those charges is not symmetrically oriented.
I think that's more adsorption chemistry you're talking about. When you have very, very high surface area carbon, just like activated charcoal, for example, it just likes to adsorb things.
Right. What I'm specifically talking about, though, is a true monopole in the genuine sense would be something that just had a single pole. So an electron is a true monopole, right? It only has one single charge. A proton is a true monopole. only has one single charge. When talking about, this on a macro scale, you'd almost have to find a way to cluster these materials together, which is why electrets are great. And, listening to Ron Kita, which I'd like you to actually look into, if you've looked into Ron Kita's work yet, or if you haven't, I'd encourage you to. He talks about a number of ways to generate monopole materials, as in materials that have either a net lack or a net excess of electrons, therefore giving them a net monopolar charge, and therefore they will not respond to a motional electric field in the same way that, say, a balanced material, like almost everything else that we see in everyday matter, is.
Yeah, but that's electric field though. So with magnetic field, it's just really difficult compared to electric field to move the poles relative to each other. But there's nothing physically saying that you can't move them arbitrarily relative to each other. For example, in spin glasses, like I mentioned to Jeremy at some point, you can move these around. Essentially, the magnetic monopoles become quasi-particles in the material. So, I mean, there's ways to move these poles around relative to each other, and that's really all that means. Like there was a video that I think you guys found a while back where someone made a solenoid coil where one of the poles was larger than the other, was like a cone shaped, and they were able to get a magnet to fire through the thing. Instead of getting trapped in the middle due to the geometry of the thing. And when you take that integral, but that's what we're talking about. Now one of the poles is spread out relative to the other. It's moved around. You just change the shape of the coil. You get a different, you just move these things relative to each other. So, I mean, you need essentially a metamaterial or you need to make a quasi-particle in matter. But I mean, effectively, if the poles are far enough apart, as distance goes to infinity, limit case, it behaves like a monopole. Anyway, but there were many other things discussed. Were there any other questions?
Okay. Well, I think so. Why don't we do this? Thank you again for the presentation. I think Mark, did you have something, or are we going to open discussion?
Just a short thing. I wanted to show the electromagnet that arrived, and there was a couple mystery items that were that came with it.
Okay. Well, so again, let's thank SPFL for his contribution and for that presentation. I think that worked out pretty well. It was a little slow to get started, but but definitely some good material there towards the end. And I will try and do the best write-up I can on that from the slides and stuff.